Add-on solutions. Add-on desires.
Welcome to Add Solutions. Hi, this is Ramakrishna. So now we discuss the topic is atomic structure. So this chapter is first intermediate chapter. So later go to the start the session. So first introduction. So in this chapter we can discuss the what is meant by atom and what are the inside atom and structure of atom. So let us see the first. In ancient days, atom is a indivisible particle and also it is a fundamental building blocks of the matter. So and later Dalton is a first scientist who proposed by the atomic theory, that is called John Dalton atomic theory. So according to the him, atom is a hard and structureless, it is a indivisible particle and also ultimate particle of the matter. So later 19th century the atom can be divisible. So atom also divisible into the subatomic particles. What are they? Electron, proton, neutron are called the fundamental particles because of these three particles are the main constituents of the atom. And next, in addition to the electron, proton, neutrons, some atoms also having the positron, neutrino, meson and antiprotons. And next we go to the in detail of the characteristics of these electron, proton, neutron subatomic particles. Let us start the electron. So characteristics of the electron. So in that characteristics of the electron we know about the charge and mass, etc. So let us see the characteristic of electron means the electron is discovered by the J.J. Thomson. So by the cathode ray X-ray tube. So now we discuss the characteristics of the electron. So one of the fundamental particle. So the electron discovered by the J.J. Thomson by the cathode ray tube experiment. So in that cathode ray tube experiment, the glass cathode ray tube is made up with the glass and it having the two thin sheets of the metal rod. So these acts as a electrodes. So one is a cathode and other one is a anode. So in that one we can adjust the vacuum pump. So different gases having the different pressures. So by adjusting of the vacuum pump, and this experiment at the low pressure. So the low pressure is 0.01 mm of Hg and next to at high voltage 10,000 volts. So in that cathode ray experiment, the cathode rays are travel from the cathode to and towards the anode. So these are the not visible by the themselves. So but we so by observe the behavior of these cathode rays by the fluorescent material. So these rays are the hit by the fluorescent material, it is a glows up. So and next these rays in the absence of magnetic field and electric field, these rays are travel straight lines. In the presence of electrical and magnetic field, these behave like a negative charged particles. Means in the presence of electrical field, so these rays are towards the positive electrode side. So itself it having the negative charge particles. So means these negative charge particles are called electrons. So named as electrons. So what is the charge of electron? So next go to the charge of electron. So the charge of electron is minus 1.6022 into 10 to the power of minus 19 coulombs. The charge of electron is discovered by the Mulligan by the oil drop experiment. And next J.J. Thomson also calculated the charge mass ratio, that is called 1.75882 into 10 to the power of 11 coulombs per kg. And next we go to the mass of electron. The mass of electron calculated by the actually mass of electron is equal to charge by charge mass ratio, means put the value. So minus 1.6022 into 10 to the power of minus 19 coulombs by So ratio is 1.75882 into 10 to the power of 11. So we get the value. So that value is mass of electron. So 9.1094 into 10 to the power of minus 31 kg. So this is we get the mass of electron. And the next particle is proton. So next particle is proton. So proton having the discovered by the Goldstein by using the perforated cathode in discharge tube. Means in discharge tube there is a perforated cathode, means it is a metal disc with the canals, means these canals metal disc act as a perforated cathode. So it acts and it is a anode. So the rays are from the cathode towards the anode. So they having the negative charge and the positive charge or the passes through these canals. So that is called canal rays or positive rays. The nature of the positive charged particles depends upon the nature of the gas filled into the discharge tube. And next, the behavior of the particles in the magnetic field or electrical field opposite to the cathode rays, because of cathode rays having the negative charge. So these are the behavior of the particles, means in the presence of electrical field, these positive rays means these particles towards the cathode side. So itself it having the positive charge. So a positive charge particles are called canal rays or positive rays. And also in the cathode discharge tube, the hydrogen gas filled in the discharge tube. So these particles or positive particles are called proton, named as proton. So the charge of proton is plus 1.6022 into 10 to the power of minus 19 coulombs, and mass of the proton is equal to 1.67 into 10 to the power of minus 27 kg. So this is the proton, about the proton. Next particle is neutron. So characteristics of the neutron. So another particle, neutral particle is neutron. So these particles discovered by the Chadwick by the bombarding of the thin sheets of the beryllium sheet by the alpha particles. So the alpha particles means helium nucleus, also known as the alpha particles. These alpha particles can bombard to the beryllium sheet to produce the neutron. And next, the charge of neutron is 0 and the mass of neutron was 1.675 into 10 to the power of minus 27 kg. It is a resemble with the mass of proton. And E by M ratio means charge mass ratio is also 0, because of charge is 0. So charge by mass ratio is also 0. We short view of these particles. These fundamental particles are electron, proton, neutron. These are short view and symbol discoverer, and next absolute mass charge and relative charge and absolute mass. So let us see the electron and symbol E, and discoverer Thomson by absolute charge is minus 1.602 into 10 to the power of minus 19 coulomb, and relative charge is minus 1, and absolute mass is 9.1094 into 10 to the power of minus 31 kg. So kg is a unit for the mass. And next, proton, the symbol is P, and it discovered by the Goldstein. So absolute charge is equal to plus 1.602 into 10 to the power of minus 19 coulomb, and relative charge is also plus 1, and next absolute mass is 1.67 into 10 to the power of minus 27 kg. And next, neutron. So neutron is a neutral particle and symbol is N, and discoverer is a Chadwick, and absolute charge is equal to 0. There is no charge, and relative charge also 0, but it having the mass. So it is a resemble with the same similar mass of the proton. So 1.675 into 10 to the power of minus 27 kg. So these are short view and fundamental particles. And next we go to the, so let us discuss the atomic models. So in that atomic models, the charged particles, how to arrange the atom. So in that first one, Thomson model of atom. So according to the J.J. Thomson, so atom possesses a spherical shape and the positive charge is distributed in uniformly and the electrons is embedded. So embedded means like a watermelon, the seeds like a seeds, the electrons are embedded into the whole positive charge of the atom. So this is a give to the stability of the atom. This is the Thomson model. So it is a resemble to the watermelon. That's why it is a watermelon model. And next, so let us start the Rutherford alpha ray scattering experiment. So from this experiment, when the source of alpha particles struck on the thin gold foil and it produced a tiny flashlight on the fluorescent screen. So what user observation for this experiment is most of the alpha particles passes through a atom and few fractions of the alpha particles are deviated some angles and few particles alpha particles are turned back. So he concluded that most of the atom is empty. So by the alpha particles are passes through the atom undeflected and few alpha particles are deflected by some angles is caused by the positive charge is concentrated in the small region. So that's the reason the particles are bounced back. From these alpha scattering experiment, Rutherford gave a nuclear model of atom. So what is the conclusions above experiment? So the most of the mass of the atom and the positive charge of the atom is concentrated at a small region. That small region is called nucleus, and this nucleus is surrounded by a electron. This is called electron. This nucleus surrounded by the electron and it is around the nucleus with a high speed in a circular path. These circular paths are called orbits. And there is a strong electrostatic force of attraction between the nucleus and electron, and it is a stability of the atom. And what are the drawbacks into the Rutherford nuclear model of atom is, so what are the drawbacks means, first, this model cannot be explained the stability of atom. It means electron revolving around the nucleus in a circular path. This circular path is called orbit. So according to the electromagnetic radiation, so it is emits the energy and the orbits are the continuously shrink, and but it not happens into the atom. So he could not explain the stability of the atom. And next, he does not explain the electronic structure of the atom, how to arrange the electrons into the atom. These are the drawbacks of the Rutherford model. And the next concept is atomic number. So what is meant by atomic number means it is denoted by the capital Z. That is, Z is equal to number of protons in the nucleus of an atom or number of electrons in the neutral atom. So we taken as a atomic number. So let us see example for the atomic number. Suppose sodium having the atomic number is 11. So 11 means 11 protons. It having the 11 protons and 11 electrons. So what is meant by atomic number? Number of protons in the nucleus of an atom or number of electrons in the neutral atom. So sodium is the atomic number is 11. So 11 protons and it having the 11 electrons. And next to go to the mass number. So mass number denoted by the capital A. So mass number is equal to number of protons plus number of neutrons. It give to the mass number of the element. So how to represent means, so this is the element, X is a element and Z is the atomic number and A is the mass number. Z is atomic number, A is the mass number. So next isotopes. What is the definition of isotopes? So same elements having the same atomic number but different mass number, that those are called isotopes. So isotopes example is protium, deuterium, tritium. These three are the isotopes of the hydrogen. So let us see the, so hydrogen is the same element in the three, and what is the atomic number? So in the deuterium also one is the atomic number, tritium also one is the atomic number, same atomic number but different mass number. These having the different mass number. So these three are the isotopes of the hydrogen. And next to isobars. So isobars. So what is meant by isobars? Different elements having the different atomic number but same mass number. So those are called isobars. These are carbon having the atomic number 6 and mass number 14, nitrogen atomic number 7, mass number 14. These two are the different elements having the different atomic numbers but same mass number. So those are called isobars. And the next example, so argon, potassium, calcium. So argon having the 18 atomic number and the next 40 is the mass number. Potassium having the 19 atomic number, 40 is the mass number, and the calcium having the 20 is the atomic number, 40 is the mass number. These three elements having the different elements having the different atomic number but same mass number. So these are the example for the isobars. And the next isotones. So isotones means all are different. So let us see the carbon, nitrogen, oxygen. These three are the different elements having the different atomic number and also having the different mass numbers. So carbon atomic number 6, nitrogen atomic number 7, oxygen atomic number 8. These three elements having the different atomic numbers and different mass numbers. So 14 is the mass number of the carbon and 15 is for the nitrogen, 16 for the oxygen. So these are the isotones. And next we go to the developments leading to the Bohr's model of the atom. So what are the developments before the Bohr atomic model? Means dual character. So introduce a dual character of the electromagnetic radiation, though both having the wave nature and particle nature. So we go to the electromagnetic radiation. So what is meant by electromagnetic radiation? Means when a charged particle under the acceleration alternating the electric field and magnetic field, they propagate in the form of wave. So this is called electromagnetic wave or electromagnetic radiation. These electromagnetic radiation having the certain characteristics. So what are they? Wavelength, frequency, velocity, wave number and amplitude. So these are the characteristics of the electromagnetic radiation. So already we know the wavelength lambda and frequency nu and velocity c, wave number mu bar and amplitude A. And next is electromagnetic spectrum. So in that electromagnetic spectrum, so how to arrange the electromagnetic spectrum? Means there is an arrangement of different electromagnetic radiation with increasing of the wavelength and decreasing of the frequency. So that is called electromagnetic spectrum. In that electromagnetic spectrum, gamma rays, X-rays, UV, ultraviolet rays and visible light. So this region is a visible light and this region is visible light and infrared and next radio waves. So increasing order of wavelength, the visible light is wavelength 400 nanometers to 700 nanometers. This is the electromagnetic spectrum. Next, particle nature. So particle nature, in that particle nature, black body radiation. So what is meant by black body? So black body means it is a perfect emitter and absorber. So means definition of the black body is it which a body which absorb the all type of radiation in all conditions and also emits the which absorb the radiation is called black body, and the black body kept into the high temperature, the emitted radiation is called black body radiation. And next to Planck's quantum theory. So what is Planck's quantum theory? In that Planck's quantum theory, so absorbed radiation or emitted radiation in the form of small packets. These small packets are called as quantum. And each quantum having the definite energy, the energy is directly proportional to frequency of the radiation. Means E is equal to remove the proportional, E is equal to h into nu. So where h is equal to Planck's constant, that value, Planck's constant value is 6.625 6 into 10 to the power of minus 34 joule per second. Okay, now this is the Planck's constant value. Next, photoelectric effect. So what is meant by photoelectric effect? We see the experiment. So this is the experiment photoelectric effect. So what is meant by photoelectric effect means when the suitable light incident on the metal surface, the ejection of electron takes place from the metal surface. This phenomena is called photoelectric effect. So when the light suitable frequency incident on the metal surface, this is the metal surface, the ejection of electron takes place from the metal surface. This phenomena is called photoelectric effect. And so next, Einstein explanation of the photoelectric effect. So how to explain the Einstein means the total energy is equal to W plus Ke. So W means work function and Ke is the kinetic energy. So work function is equal to h nu and h nu naught plus of mv square. So where nu is frequency, nu naught is threshold frequency. So what is meant by threshold frequency? The minimum frequency to require the ejection of electron from the metal surface, that is called threshold frequency, and of mv square is the kinetic energy. Means Einstein can explain the photoelectric by the total energy, absorbed by total energy, it is converted into work and kinetic energy. Means some energy converted into ejection of electron, utilized for the ejection of electron, and remaining energy is converted into kinetic energy. So this is the Einstein explanation for the photoelectric effect. And next, so features of the atomic spectrum. So in that features of the atomic spectrum, one is the types, means absorption spectrum, emission spectrum, line spectrum, band spectrum. Okay. So in that absorption spectrum, the absorption spectrum produced by the absorbed radiations, it is corresponding to the electron jumps from lower energy level to higher energy level. Suppose n is equal to 1, n is equal to 2. When the energy is absorbed, the electron goes to the higher energy level. So that radiation is caused by the absorption. So let us start the Bohr's model. So the question framing is, what are the postulates of the Bohr's atomic model, and explain the hydrogen spectrum. So let us start the Bohr's model and the postulates. So what are the postulates means? First postulate is the electron revolving around the nucleus revolving around the nucleus in a circular path. These circular paths are called orbit. And each orbit having the definite energy. So these orbits are called energy levels. These are designated by the KLMN over 1, 2, 3, 4, so on. And next, as long as electron revolving around the nucleus neither absorb the energy nor emit the energy, so the energy of the orbit is constant. So these are called stationary orbits. And next, the electron revolving around the nucleus with the angular momentum. The angular momentum of the electron MVR is equal to NH by 2 pi, means integral multiple of h by 2 pi. So we explain the terms. So m is equal to mass of the electron, and v is equal to velocity of the electron, and r is equal to radius, and n is the integer. And next, h is equal to Planck's constant. So the value of the Planck constant is equal to 6.626 into 10 to the power of minus 34 joule per second. It is a SI unit, and also 6.626 into 10 to the power of minus 27 erg per second. These are the series units. And the next, 2 pi. So this is the angular momentum of the electron. We can calculate the use of this formula. And the next, the electrons jumps from lower energy to higher energy level, and higher energy level to lower energy level, the energy is absorbed or emitted. So when the energy is absorbed, the electron jumps from lower energy to higher energy level. The electron jumps from higher energy to lower energy level, energy is emitted. This is the emitted radiation. absorbed radiation. So electron jumps from lower orbit to higher orbit, energy is absorbed, and the electron drops from higher orbit to lower orbit, energy is emitted. So the difference energy we can calculate is equal to higher energy level minus lower energy level, E2 minus E1, and also is equal to h nu. From the E is equal to h nu. So these are the postulates of the Bohr atomic model. And the next, Niels Bohr can explain the hydrogen spectrum. So let us see the hydrogen spectrum. When hydrogen gas is subjected to the electrical discharge, so the hydrogen molecules can absorb the energy. So the electrons can absorb the energy, go to the higher energy level. In the higher energy level, it is unstable and they return back to the ground state with the emit the radiation. So these emit the radiation placed into the spectrometer. It give the line spectrum of the hydrogen. So line spectrum means the line spectrum consists a series of lines, and each series of lines consists a certain wavelengths. Okay, so these 5 lines are appear in the hydrogen spectrum. So let us see the how it is formed. So when the electron jumps from higher energy level to lower energy level, so means, so n is the first energy level, 2, 3, these are the energy levels. So the electron drops from higher energy level to lower energy level. First is the second energy level is also higher than the first energy level. So the electron jumps from higher energy level to first orbit. So higher orbit to first orbit, that series is called Lyman series. Suppose the electron, also suppose third energy level is also higher orbit. So the electron drops from higher orbit to first orbit, that appears series is called Lyman series, it in the UV region. And next, the electron drops from higher orbit to second orbit, so it is a Balmer series, it appears at visible region. And next, higher orbit to the electron drops from higher orbit to third orbit, that series is called Paschen series. And next, the electron drops from higher orbit to fourth orbit, that series is called Brackett series. And next, fifth orbit is the Hund series. These Paschen series and Brackett series, Hund series appears at the IR region, so infrared region. So it is a Paschen series, it appears it near IR region, and Brackett series appears at the middle IR region, and the next Hund series is appears the for IR region. So means that region means they having the certain wavelength. Suppose UV region having the certain wavelength, and visible region it having the 400 to 760 nanometers. Next, so what are the limitations of the Bohr model? So it fails to explain the fine structure of the hydrogen spectrum. And next, it does not explain the Zeeman effect and Stark effect. So Zeeman effect means the spectral lines in the presence of magnetic field. And the spectral lines in the presence of Stark electric field, that is called Stark effect. He does not explain the Zeeman effect and also Stark effect. And next, he could not explain the ability of the atoms to form a molecules by the chemical bonding. These are the limitations of the Bohr's atomic model. So question is, framing of the question is, what are the postulates of the Bohr atomic model, and explain the hydrogen spectrum, and limitations of the Bohr model is, this is the Bohr atomic model. And next, go to the radius of the orbit. So we can calculate the radius. R is equal to n square h square by the 4 pi square me square. So h is equal to Planck's constant. Already we know the two values in the SI system and CGS units. And the next, 4 pi square, and m is the mass of electron, is the charge. So next, radius of the orbit in the hydrogen atom, like the helium plus lithium plus 2, barium plus 3. So hydrogen atom having 1 electron, and like helium plus means 1 electron, lithium plus 2 is 1 electron, and beryllium plus 3 is 1 electron. So we can calculate the R value. R is equal to 0.529 into n square by z, it angstroms. So this is the radius of the orbit, and next we discuss the dual behavior of the matter. So dual behavior of the matter means the particle having the both wave nature and particle nature. So de Broglie's hypothesis, so he proposed one equation. So for the lambda means we can calculate the wavelength so of the particle. So E is equal to h in nu. So from the according to the Planck's quantum theory, E is equal to h nu. So already we know the nu is equal to c by lambda. So just substitute the new value. So h c by lambda, it is equation number 1, and from the so according to the Einstein equation, so E is equal to mc square, it is equation number 2. From the equation number 1 and equation number 2, these both are equal. So we see the hc by lambda is equal to mc square. So we can cancel the c on the both sides. So h by lambda is equal to mc. So where lambda is equal to h by mc. C is the velocity of the light, but the velocity of the particle is v. So we just substituted the instead of the c, v. So lambda is equal to h by mv. So where mv is equal to momentum. So we can write also lambda is equal to h by p. So lambda is equal to wavelength, and h is equal to Planck constant, p is equal to momentum. So momentum is equal to mass into velocity. So in the above equation, lambda is equal to Planck constant by mass into velocity. So these are the de Broglie's hypothesis. And next we go to the Heisenberg uncertainty principle. So what is meant by Heisenberg uncertainty principle means it is impossible to determine the exact position and exact momentum of the electron. So revolving electron, suppose when electron around the nucleus, so it is impossible to determine the exact position and exact momentum of the electron simultaneously. So they gave the equation, so delta x into delta p, so greater than or equal to h by 4 pi. So where delta x is equal to position of the electron, and delta p is equal to momentum, p is equal to momentum, and h is equal to Planck constant. So that is called Heisenberg uncertainty principle. And next we go to the important topic is quantum numbers. So in that quantum numbers, so first there are the 4 quantum numbers: principal quantum number, and azimuthal quantum number, magnetic quantum number, and spin quantum number. First one, principal quantum number. So principal quantum number is proposed by the Niels Bohr, and it is denoted by the small n, and the values of the n is equal to 1, 2, 3, 4 or KLM so on. So it is the number of orbitals in the energy level is equal to n square is the formula. So just we can calculate the, suppose example, second energy level. In the second energy level, how many number of orbitals in the second energy level? Just 2, where n is equal to 2. So it is 4. So 2s and 2p. So these 2 orbitals in the second energy shell. So we can calculate the any energy level. So number of orbitals in the energy level is equal to n square, and the next number of electrons in the energy level is equal to 2n square. Suppose in that second energy shell, how many electrons present in the energy level is equal to n is equal to 2. So we can substitute the n value in that formula. So 2 into 2 square. So 2 square means 4. So 4 2s are 8. So it having the 8 electrons. The second energy shell having the 8 electrons. So it is 2s2 2p6, total 8 electrons in that second energy shell. And the next significance. So significance means importance. This principal quantum number tells about the size and energy of the orbit. So next go to the azimuthal quantum number. So this azimuthal quantum number discovered by Sommerfeld, and it denoted by the small l. The L values are the 0 to n minus 1. And what is the significance of these azimuthal quantum number means? So it tells about the size of orbitals. So what is the significance means? The azimuthal quantum number, it tells about the shape of orbitals. So the L values is 0, 1, 2, 3 and subshells S, P, D, F. So mean S subshell, it having the L value is equal to 0, and P subshell L value is equal to 1, and D is equal to 2, F is equal to 3. The shape of the S orbital is a spherical, and shape of the P orbital is a dumbbell, and the next D orbital is double dumbbell, and F orbital, shape of the F orbital is complex structure over fourfold. And we see the orbital structure also. So next quantum number is magnetic quantum number. So magnetic quantum number proposed by the Lande, and it denoted by the small m. The m values are the minus L to plus L, and the number of orbitals in the subshell is the formula 2L plus 1, where the L value is equal to 0, 1, 2, 3, 4. So we substitute the L values, we get the number of orbitals in the subshells, and also number of electrons in the subshells 2 into 2L plus 1. And the next significance, their magnetic quantum number tells about the orientation of orbitals in the space. So the m values are, suppose S, P, D orbitals. So L value is equal to 0, 1, 2. So m values. So m values are the 0 for the s orbital, L value for the p orbital, L value is equal to 1. So m values are minus L to plus L, means minus 1, 0, plus 1. And next D is equal to, L value is equal to 2. So what are the m values? Minus 2, minus 1, 0, plus 1, plus 2. So these are the m values like that. So F has the 3. So F, for the F orbital, L value is 3, and m values are the minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. Okay. So these are the m values. This is the magnetic quantum number. And the next, last one, spin quantum number. So spin quantum number proposed by the Uhlenbeck and Goudsmit, it denoted by the small s. The s values are minus of, plus of. Minus of means clockwise direction, and so plus of means clockwise direction, and minus of means anti-clockwise direction. So we show in the figure. So s is equal to s value plus of means clockwise direction, and s is the minus of means anti-clockwise direction. So what are the significance of the spin quantum number means? It tells about the direction of spinning of electron. So whether the clockwise or anti-clockwise. So this is the spin quantum number. And next go to next topic is shape of the orbitals. So already we know the s orbital, p orbital, d orbital. So these are the atomic orbitals. The shape of the s orbital means these orbitals along the 3-dimensionally. So it is a spherical shape. S orbital is spherical shape. This is the shape of the orbital. And the next shape of the p orbital is, it having the px, py, pz. So p having the 3 degenerated orbitals. These 3 are the degenerated, means same energy. So px, py, pz. So the orbital, the dumbbell shape. So p orbital shape is dumbbell. The orbital lie on the x-axis, it is a px, and y-axis py, and along the z-axis, that is a pz orbital. And the next d orbital. So d orbital, shape of the d orbital is double dumbbell. These in that one 5 degenerated orbitals. D having the 5 degenerated orbitals. So one is a dxy, dyz, and dzx, and dx square minus y square, and dz square. These 5 are the degenerated orbitals. These orbitals in between the axis, dxy, dyz and dzx are the lie in between the axis, and dx square minus y square on the axis. The orbitals lie on the axis, and these two are the lie on the axis. This is the shape of the d orbital. And next go to the filling of orbitals into the atoms. So how to fill the orbital into the atoms? So let us see the Pauli's exclusive principle. First one, Pauli's exclusive principle. What is this principle? Means no two electrons in the same atom can having the same set of 4 quantum numbers. Means suppose we can consider 1s2. So 1s2. So 1s2 having the 2 electrons. For the first electron, n value is equal to 1, means it lie in the first energy shell. So n value is equal to 1 and L value is equal to 0. So for the s orbital, L value is equal to 0, and the next m value also 0. So because of what are the m values? Minus L to plus L. So minus L is equal to 0, so m value is also 0, but s, so plus of for the first electron. Second electron, for the second electron, n value is equal to 1, L value is equal to 0, m value is equal to 0. Because of the second electron also lie in the s orbital. So next, s value minus of, so anti-clockwise. One is a clockwise direction and another one is a anti-clockwise direction. That's why the s values are different. So in that one, 1s2 having the, so these three are the same, up to m values are same, but spin quantum number is different one. That's why the no two electrons in the same atom can having the same set of 4 quantum numbers. Clear? And in the Pauli's exclusive principle means it accumulate, each orbital accumulate the only 2 electrons with opposite spin. So opposite spin means one is a plus of and other one is a minus of. So we can write like that. And next rule is Bohr principle. So Bohr principle means the distribution of the electrons into the orbitals with the increasing order of energy. So means first we fill the lower energy level, after we fill the higher energy level. So let us the Moiler diagram. This is the Moiler diagram. So 1s, 2s, 2p, 3s means first fill the electron into the 1s, next 2s, next 2p. This is the energy order. So after 3p, filled first, 4s orbital is filled first, next to 3d. So why? Because of there is energy difference. 4s is the lower energy than the 3d orbital. That's why the 4s filled first after the 3d. Next, Hund's rule. So what is meant by Hund's rule? Means in the degenerated orbital, the electrons filling in the degenerated orbitals. So first, suppose in the degenerate orbitals p4. So first we fill the electron each one after the pairing. So this is the Hund's rule. So according to these are the total atomic structure. So to use these rules to fill the electrons. So okay, thank you. So this is the total chapter.
Add-on solutions. Add-on